Hi, welcome to Bits and Proofs. Today's a foundations lesson, vector databases and how they make it possible to search millions of embeddings in milliseconds. Here is the full pipeline. Your documents go through an embedding model. Each document becomes a list of numbers. Those numbers go into a vector database. When a user asks a question, the database finds the closest embeddings. The matching text is handed to the AI, and the AI gives an answer. This whole chain is called RAG. Last video, we covered embeddings. We learned how text becomes a list of numbers. Today, we focus on the next step, vector databases. This is the piece that makes fast search possible. Let us look at the problem. You have embedded 1 million help articles. Each article is now a vector stored somewhere. A user asks, how do I reset my password? You embed the question. Now you need to find the closest vectors in your database. The obvious approach is to go through every vector one by one and compare. Here is the problem with that. At 1 millisecond per comparison, 1 million comparisons takes 17 minutes. No user will wait 17 minutes for a search result. This approach does not work. A vector database is a database built specifically for this problem. Its only job is to store vectors and answer one question: what is the closest vector to this one? It is not a general database. It does not replace your main database for storing users or orders. It is a purpose-built tool designed for exactly this one task, and it does it far faster than any general database could. So how does it get so fast? The key idea is indexing. When you insert vectors, the database groups similar ones into regions. Look at this picture. Each cluster of dots is a region. Similar vectors land near each other. When a new query arrives, the database figures out which region the question belongs to. Then it searches only that region. Instead of checking all 1 million vectors, it might check only a few thousand. The result is almost the same. The work is a tiny fraction. This fast approach has a name, Approximate Nearest Neighbor Search, or ANN. The word approximate is important. It does not always find the exact closest vector. To skip regions quickly, it sometimes misses a slightly better match in another region. The result it returns is very close, but not always the perfect best. For search, this is completely fine. If the exact best match has a similarity score of 0.94 and the approximate result scores 0.92, the user cannot tell the difference. Both return the right article. The speed gain is enormous, and nothing important is lost. A vector database supports 3 main operations. The first is insert. When you index your documents, you store each embedding together with its source text and a unique ID. The second is query. You give the database a vector, the question embedding, and ask for the top k closest matches. This is the search step that happens on every user request. The third is delete. When a source document changes or is removed, you delete its embedding from the database. This keeps your search results accurate and up to date. Let us see what this looks like in code. At index time, you call insert once for each document. You pass an ID, the embedding of the text, and the text itself. At query time, you call query. You pass the embedding of the user's question and ask for the top 3 closest results. The database returns a list. Account recovery steps is at position 1. The right article was found, even though the question and the title share no words. This is the whole power of vector search. Now let us look at the tools available. There are several popular vector databases. Chroma is local and free. It is great for prototypes and learning. You can run it on your own machine with no setup. Pinecone is a managed cloud service. You do not run any servers. It is built for production at scale. pgvector is a Postgres extension. If your team already uses Postgres, you can add vector search without switching to a new system. Weaviate is open source and can run on your own servers or in the cloud, giving you full control. Choosing between them is straightforward. If you are building a prototype or learning how this all works, start with Chroma. It costs nothing and runs on your laptop. If you are launching a product in production and want someone else to manage the infrastructure, use Pinecone. If your team is already on Postgres, pgvector is the easiest path. You add one extension and your existing database gains vector search. No migration needed. Let us bring it together. 3 things to remember. 1. A vector database stores embeddings and finds the closest ones fast. That is its only job, and it does it very well. 2. It uses indexing to group similar vectors. At query time, only the right group is searched. Most of the data is skipped. 3. Results are the most similar documents, not the exact closest. Close enough is the goal. For search, it is always good enough. You now have the 2 key pieces. Embeddings turn text into numbers. A vector database stores those numbers and finds the closest ones fast. Put those 2 pieces together with a language model and you get RAG, an AI that can look up the right information from your own data before it answers. That is the next video in this series. Thanks for watching. If this helped, do subscribe. More AI engineering content is coming soon. And while you are here, check out the other AI engineering videos already on the channel. See you in the next one.